So, hello everyone. We are group number 9, and today we will introduce to you the construction of a virtual supply chain using an enterprise e-catalog. So, this is our list of contents. Next will be the introductions. So, what is the virtual supply chain? In simple words, it's a mirror information model of a physical supply chain and is applied in many circumstances, such as the utilizing information and particular mathematical models, controlling component in a smart factory system, or a multi-agent and agent-based system. And this paper proposed a new method which construct a virtual supply chain as a multi-agent system, which software agents from selected component enterprise model are connected. Next, we'll, uh, next slide, please. Uh, so let's talk about the usage of a virtual supply chain. So one of the most popular usage of a virtual supply chain is optimizing the supply chain, which is the optimization of configuration, plan, schedule, control, etc. And in this figure, as you can see, the autonomous optimization at each component is required by viewing the whole supply chain corresponding to its flexible and dynamic configuration. This requirement is fulfilled by using a methodology to construct a virtual supply chain in a cyber world. And another usage of a supply chain, which could be used to consider the adequate configuration and management of the supply chain. It used to search for a better trading partner in a cyberspace, make a public recruitment of a trading partner in cyberspace, and review a behavior pattern for deciding on an enterprise beneficial actions. And next will be the construction of virtual supply chain.
So next slide, please. So the first one is agent-based construction using enterprise e-catalog. So this method builds a virtual supply chain using enterprise e-catalogs, where each component catalog is represented as a software agent. E-catalog, including template, meaning general model for enterprise types, including behavior. And next, we have item, meaning specific instance with detailed values and representing a specific enterprise. So step for construction, the first one we will select enterprise models, meaning choosing enterprise item like retailer, manufacturer, supplier, and from the e-catalog. Next, we are generating enterprise agents, automate automatically create software agents for each selected enterprise item. And the final, we will build the virtual supply chain, meaning connecting the enterprise agents into a multi-agent system to form the virtual supply chain. So next we are going to enterprise e-catalogs. Next, please. So the enterprise template define behaviors as a combination of state and state transition, including scheduling method, decision-making conditions, calculation formulas with variables, and related data. So we are going through retailer e-catalogs. Behavior of a retailer, which is a sales enterprise, is modeled as a UML, Unified Modeling Language. Activity diagram shown in Figure 5. Each activity shows a state of a retailer. A state transition occurs by interaction with a manufacturer, making a decision, or completing an action. Next, please. So this is table one. The table one shows parameter for a retailer. Parameters are divided into two types. The first one is parameter for a retailer item, meaning refer to in the activity simulation of the behavior part and affecting the retailer behavior. And concrete value for the first one is parameter are provided when the retailer item is created from the template as a fixed value, a formula including variables or conditions with variables. And next is variables are provided by property parameter or by supply chain configuration data when the virtual supply chain is constructed. And they are provided by order data and data for order goods when the simulation is executed. And the second one is parameter for selling goods, and they are these parameter are prepared for each of the goods when the retailer item is registered. And the dynamic behavior of a retailer is modeled as state and state transition by referring to an activity diagram and using parameters. So this is table 1. Next, please.
Now we'll be moving on to the manufacturer e-catalog. This is the similar UML model. It also shows a state of activities. These process also make sure that information between departments are accordingly and while preventing defects and waste. It's show activities as states from waiting for orders to waiting for production orders and ends with testing and packaging. Some of the states are happening simultaneously with the retailer. And some of the state also requires completion from another e-catalog department, such as supplier selection for needed parts. They need to have the estimation for required request products and etc. After parts are received, we now look at the parameters used for a manufacturer throughout the process. Parameters are used to categorize the parts for production and also the finished product. Each activities in the UML diagram involves specific parameters from the table 2 that determine how the process function. These parameters also used for calculation simultaneously within the process. This also creates the dynamics within this e-supply chain catalog. Moreover, in the next slide, it also shows the process outputs, which are production costs, stock costs, and all the way to total production time. These are the key metrics which are essential for optimizing the supply chain in the future.
Next, we have the supplier e-catalog. The dynamic behavior and operational states of a supplier in the virtual supply chain are illustrated through a UML activity diagram, showing key steps in processing manufacturer requests. In the first step, we have waiting for order. The supplier is in a passive state, awaiting for order requests. A request for parts estimation triggers the next step, which is scheduling of production. In this step, upon receiving a request, the supplier schedules production, assessing resources and capacity. Estimated costs and production times are then sent to the manufacturer. In the next step, which is waiting for production order, the supplier awaits confirmation or cancellation. If the order is canceled, the procedure returns to waiting for order state. And if the order is accepted, it will trigger to manufacturing state when the production begins based on the agreement on quantity, quality, and timeline. The estimation parts then undergo quality assurance testing in the testing state, And after successfully tested, parts are packaged and ready for delivery. In addition, each activities in the UML diagram involves specific parameters that streamline the operational flow. By defining which parameters belong to their state, we can calculate the cost incurred by simulating the supplier. By integrating the diagram and parameters table, the supplier enterprise can enhance their performance by simulating different situations and cases, which will also enhance the performance of the whole virtual supply chain by enhancing the flexibility and quality control, and also reducing delays.
Next, we will move to the configuration system for virtual supply chain. Next, we will move to the e-catalog receipt station. And this picture that we show an enterprise item, which is a concrete model of a specific enterprise is automatically generated by filling up a parameter in the corresponding template that using the input value, data formula, and condition. And this picture show the display while inputting the parameter values for the manufacturer item, and the HTML description for the manufacturer item was output and saved. Next, we will move to the simulation view configuration. And in this picture display the data, retailer item, and manufacturer item, and supplier items are selected from the catalog, and retailer agent and manufacturer agent and a supplier agent are automatically generated, and generated agent are connected to the configure virtual supply chain. Next, we will have the picture, and this picture is a display when the simulation is executed. According to the order data, the retailer agent orders product, and the manufacturer agent sources part, and the manufacturer the product. And when the simulation is executed according to the order data, the retailer agent order product. And so this picture we have an example display when executing a simulation of the constructed virtual supply chain.
So the last part will sum up the key points up until this moment. The paper concludes that the virtual supply chain constructed using the proposed Unified Modeling Language, UML, learning from the paper's established framework, we could standardize and apply the method into the real supply chain setting. This template also enables us to considering the indices to simultaneously cover vital elements, such as computation in previously displayed tables. There still remains some limitation due to the fact that this paper only introduced generalized details without fully advised supply chain digitization. The matter leads directly to us considering many further analysis and models to the stage of reaching a more full-fledged digital supply chain. And after analyzing the paper, we think that some advanced application can be applied to enhance the model's performance, such as integrating machine learning algorithms into the virtual supply chain system. which will maybe leverage the accuracy of demand forecasting by conducting a time series model like ARIMA. For example, a company can use ARIMA model based on historical data for each e-catalog, which can significantly reduce the risks of demand spike or sudden decline. Knowing the advantages of this application, some papers related to this idea can be listed as: first one, forecasting supply chain descriptions in textile industry using machine learning. And secondly, enhance supply chain management with deep learning and machine learning techniques. That's pretty much all for the paper analysis. By analyzing the paper, we know that the collaboration and connectivity between each node in the supply chain is really important. For that reason, based on what we have learned, we think that the supply chain visibility here is the key point. By sharing enough information and data between each catalogs, the virtual supply chain will surely maintain the efficiency and enhance their performance. And that's all for our presentation. Thank you for listening.